There is a moment, just after midnight, when the sky becomes depth itself. You are standing in a place with no artificial light. The air is cold against your skin. Above you, the stars are not points, but presences, each one a sun, each one impossibly distant. And among them, brighter than anything else in the darkness, is Jupiter. It does not flicker like the stars. It holds steady, a slow-moving beacon rising in the east, carrying with it something you cannot see but have always felt: the weight of scale. For as long as humans have looked up, this light has been there. The Babylonians recorded its slow dance against the fixed stars. The Greeks named it for their king of gods. And for the last few decades, we have sent machines to orbit it, to taste its atmosphere, to photograph its storms. We have come to know it as a world, a massive swirling sphere of hydrogen and helium, 11 times wider than Earth, hosting a storm that has raged for centuries. But familiarity is not the same as understanding. We look at Jupiter and see a planet, a destination, a photograph. What we do not see is the architecture, the invisible role it plays in keeping everything else exactly where it is. The way its gravity reaches across 500 million kilometers of empty space, sweeping clean the debris that might otherwise find its way to us. The way its presence tugs at the asteroids, bends their paths, keeps them contained. For decades, we have told ourselves a story, that Jupiter is our protector, a cosmic shield, drawing comets and asteroids into itself so that we do not have to. And there is truth in that. The scars on its surface from impacts we never felt are real. But protection is never absolute, and gravity does not discriminate between friend and enemy. It only acts. What we have missed in our story of Jupiter the Guardian is something far more unsettling, something hidden beneath the statistics and the orbital diagrams. A truth that only emerges when you stop asking what Jupiter does for us and start asking what keeps Jupiter, keeps everything, exactly where it is. The answer is not comfort, because the solar system is not a machine built for our survival. It is a balance. And balance, once disturbed, does not restore itself. You have likely seen the diagrams, the ones from school classrooms or science documentaries. The sun at the center, a yellow ball of light, and around it, the planets in their ordered paths, neat ellipses, spaced like beads on a wire. Mercury, Venus, Earth, Mars. Then the asteroid belt. Then Jupiter, Saturn, Uranus, Neptune. Each one following its curve through space, eternal and unchanging. It is a comforting image. It suggests permanence, that the planets have always been where they are and will always remain there, that the clockwork of the solar system was wound up long ago and simply continues ticking. But the diagrams lie. Not intentionally. They simplify. They take something too complex to visualize and reduce it to something the mind can hold. And in that simplification, they erase the thing that matters most: the fragility. The solar system is not a clock. It is a conversation, a continuous, silent dialogue between every object that orbits the sun. Every planet pulls on every other planet. Every asteroid tugs at its neighbors. Every moon exerts its influence on its parent world. Nothing is isolated. Nothing is fixed. Everything is in constant, subtle motion, responding to forces that never stop applying themselves. This is the mathematics of orbital mechanics, and it is beautiful, until you look too closely. Because the equations that describe this dance are not the simple ones you learned in school. They are what physicists call the n-body problem. For two bodies, a sun and a single planet, the math is elegant, predictable. You can calculate their paths for millions of years with perfect certainty. But add a third body. Add Jupiter. Add Saturn. Add the gravitational whisper of a passing asteroid, and the elegance vanishes. The equations become what mathematicians call non-integrable. They have no exact solution. You cannot predict with certainty where any planet will be in 10 million years. You can only approximate. You can only simulate. and every simulation carries within it the possibility of divergence. For most of human history, this did not matter. The time scales were too vast, the changes too slow. The solar system appeared stable because we were not watching long enough to see it shift. But we are watching now. And we have begun to understand something unsettling. Stability is not the same as permanence. The solar system is not in a fixed state. It is in a temporary configuration. One that has persisted for hundreds of millions of years, yes, but one that could, in theory, be disrupted. The question is not whether it will last forever. The question is what it would take to break it. And this is where Jupiter enters the story, not as a protector, but as something else entirely. Because in a system this delicately balanced, the largest object does not just stabilize, it also dominates. It holds the largest share of gravitational authority. And authority, once established, becomes impossible to ignore. If something were to change, if something were to disturb the conversation between these worlds, Jupiter would not resist that change. It would amplify it. But that is not the real problem. The real problem is that we do not know what could cause such a disturbance. We look outward and see only emptiness. We assume the space between planets is inert, that nothing happens there, that the only threats are the ones we can see coming, the asteroids, the comets, the visible dangers. We assume that silence means safety, and that assumption is about to meet something it cannot survive. There is a region of the solar system you have never seen. No human has. It exists beyond the orbits of Neptune, in the cold darkness where the sun is just another bright star. A vast reservoir of icy bodies, left over from the formation of the planets. Astronomers call it the Oort cloud. It is not a cloud in the familiar sense. There is nothing to see, no light, no color, just scattered objects, some as small as mountains, others larger than cities, drifting in slow orbit around the sun, so distant that a single circuit takes millions of years. For the most part, these objects never trouble the inner solar system. They are too far away, too bound by the faint gravitational grip of the sun. They simply exist in the dark, untouched and unobserved. But they are not isolated. Every object in the Oort cloud feels the gravity of the sun. And every object also feels something else, a whisper from beyond. The cumulative gravitational pull of the Milky Way itself, passing stars, molecular clouds, the slow, patient tide of the galaxy. Most of the time, these forces are too weak to matter. They tug at the distant comets, shift their orbits by tiny amounts, but never enough to send them falling inward. The system holds. But here is the truth that changes everything. It does not take much. A star passing at just the right distance, a slight perturbation in the galactic tide, a gravitational nudge so small that no instrument on Earth could detect it, and an object that has been circling in the dark for 4 billion years begins to fall. This is not science fiction. This is physics. We know that stars move. We know that the solar system travels through the galaxy, encountering different gravitational environments over deep time. We know that comets arrive from the Oort cloud. They always have. The question is not whether disturbances occur. The question is, how often and how large? And the answer depends entirely on something we cannot control. A single comet, dislodged from the Oort cloud, begins a long journey inward. It takes hundreds of thousands of years to cross the distance. It accelerates as it falls toward the sun. And as it travels, it passes through regions of the solar system where other objects reside. The asteroid belt, the orbits of the giant planets, Jupiter. If the comet misses Jupiter, it continues toward the sun. Perhaps it swings around and heads back out. Perhaps it impacts something else. Perhaps it passes close enough to Jupiter to feel its gravity. And this is where the mathematics become something else entirely. Jupiter does not simply deflect objects. It captures them. It flings them. It changes their orbits in ways that cannot be predicted with precision. A comet that enters the Jupiter system can emerge on any trajectory, sent inward toward Earth, or outward to the edge of the system, or into a new orbit that brings it back again and again. This is not speculation. We have watched it happen. Comet Shoemaker-Levy 9 came too close to Jupiter in the 1990s. The planet's gravity tore it apart into fragments, each one miles wide. And then, on a week in July 1994, those fragments impacted Jupiter's atmosphere one after another, releasing energy equivalent to millions of nuclear weapons. The scars were visible from Earth, dark bruises in the cloud tops that lasted for months. We called it a spectacle, a reminder of Jupiter's role as our shield. But look closer at what actually happened. Jupiter did not destroy the comet to protect us. It destroyed the comet because gravity is indifferent. And if that comet had been aimed differently, if its approach had brought it not into Jupiter but past it, the fragments would have continued inward, toward us. The shield is also a slingshot. The protector is also a redirector. Jupiter does not eliminate threats. It processes them. It takes incoming objects and scatters them in new directions, some safe, some not. We only notice the ones that miss. But here is what keeps astronomers awake. The Oort cloud contains trillions of objects. Most are small, some are not. And every few million years, something passes through the outer solar system that disturbs them. We do not know when it will happen again. We do not know what is already falling. Imagine for a moment that it has already begun. Somewhere beyond the orbit of Neptune, an object the size of a small world has been dislodged. Perhaps by a passing star, perhaps by the cumulative pull of the galaxy itself. It does not matter how. What matters is that it is now falling, slowly at first, imperceptibly, but falling. For thousands of years it travels through the darkness. No human sees it. No telescope detects it. It is too small, too distant, too cold. It simply drifts, following a path that will take centuries to cross the outer solar system. And then, gradually, it begins to accelerate. The sun's gravity pulls harder as it approaches. The object gains speed. It crosses the orbit of Neptune, then Uranus, then Saturn. Still unseen, still silent, moving now at tens of thousands of kilometers per hour. And then it reaches Jupiter. This is the moment when everything changes. Not because the object will hit Jupiter. It probably will not. The probability of a direct impact is small. What is far more likely is something stranger, something more consequential. The object enters Jupiter's gravitational sphere of influence, a region of space hundreds of millions of kilometers wide, where the planet's pull dominates over the sun's. And here, the laws of orbital mechanics create possibilities that do not exist anywhere else. If the object passes behind Jupiter relative to its orbital motion, it will slow down. Its path will bend. It may fall into a new orbit around the sun, one that brings it closer to the inner system than before. If it passes ahead of Jupiter, it will accelerate, gain energy, be flung outward like a stone from a sling. But there is a third possibility, one that changes the mathematics entirely. If the object passes at exactly the wrong distance, if it enters a gravitational resonance with Jupiter, something else begins to happen. Not a single deflection, but a repeated interaction. Each time the object completes an orbit around the sun, Jupiter is there, tugging at it. Each tug adds a tiny amount of energy. Each pass shifts its path by a fraction of a degree. Over decades, over centuries, the orbit evolves. And this is where the cascade truly begins. Because the object does not exist in isolation. It carries momentum. It carries gravitational influence. And as its orbit changes, it begins to encounter other things. The Trojan asteroids, trapped in Jupiter's Lagrange points. The main asteroid belt between Mars and Jupiter. The inner planets themselves. A single object redirected by Jupiter can become a catalyst. It collides with an asteroid in the belt, shattering it into fragments. Those fragments scatter in all directions. Some fall toward the Sun. Some intersect the orbit of Mars. Some continue inward toward Earth. But this is not the worst possibility. The worst possibility is that the object itself is large enough to matter, that it is not a comet but a dwarf world, an icy body hundreds of kilometers across, and that Jupiter, instead of flinging it away, captures it into a new orbit, one that crosses the inner system repeatedly. This is not hypothetical. We know that objects migrate. We know that resonances exist. We have observed the gravitational dance of moons and asteroids throughout the solar system. We know that chaos is not an exception in orbital mechanics. It is the baseline. Order is what is rare. What we do not know is whether such an object exists in the Oort cloud, whether one is already falling, whether the timing aligns with our present moment. But consider this. Geological records show that Earth has experienced impacts large enough to alter the course of life multiple times. The one that killed the dinosaurs 66 million years ago. The one that triggered the Younger Dryas cooling period, if that hypothesis holds. The ones that left craters buried under kilometers of ice or hidden beneath the ocean floor. We explain these as random events, statistical certainties over deep time. And they are. But randomness has structure. It clusters. It follows patterns we cannot always see. What if the pattern is Jupiter? What if the great protector is also the great distributor? What if the same gravity that sweeps the neighborhood clean also occasionally throws something back? We have no way to know. Our telescopes are not powerful enough to catalog the Oort cloud. Our simulations cannot run for millions of years with perfect accuracy. We are navigating the dark with a flashlight that reaches only a few meters ahead. But this is where the escalation takes its final turn. Because the threat is not just what Jupiter might send toward us. The threat is what happens when the system itself begins to unravel. An object large enough, redirected by Jupiter, does not just threaten Earth. It threatens the gravitational architecture of the entire inner system. It perturbs Mars. It perturbs Venus. It perturbs Earth's own orbit by tiny amounts that accumulate over millennia. And once that process begins, it does not stop. The solar system does not have a reset button. It has only momentum, only gravity, only the slow, patient rearrangement of matter according to laws that do not care what lives or dies in the process. We are not watching a machine. We are watching a weather system. And weather, eventually, always changes. There is a number that haunts the margins of planetary science. It appears in textbooks and research papers, always in passing, always with a certain reluctance. The number is 1%. Over the next billion years, the chance that Mars will come close enough to Earth to disrupt its orbit is approximately 1%. A small number, a number that allows comfort, a number that says, probably not. But probability is not certainty, and 1% over a billion years is not the same as zero. It means that in the history of the solar system, such events have likely occurred. It means that the arrangement we see today is not the only arrangement possible. It means that stability has limits, and Jupiter is at the center of this possibility. Because Mars does not orbit in isolation, it feels Jupiter's pull more strongly than Earth does. More strongly than Venus does. Mars is smaller, closer to the asteroid belt, more susceptible to perturbation, and if an object from the outer system were to alter Jupiter's gravitational field, if it were to shift the resonance patterns even slightly, Mars would respond. Not immediately, not dramatically, but over thousands of years its orbit would begin to change. The ellipse would become more elongated, the tilt would shift. The distance between Mars and Earth would vary in new ways. And at some point, the orbits would cross. Not literally. Planets do not collide like billiard balls. But they can approach close enough for their gravity to exchange energy. Close enough for Earth's orbit to feel the strain. Close enough for the equilibrium that is held for 4 billion years to finally break. What happens then cannot be predicted in detail. The equations forbid it. but the broad strokes are visible. Earth's orbit becomes more eccentric. The seasons become extreme. Winters deep enough to freeze the oceans at the poles. Summers hot enough to boil the shallows. The climate becomes a pendulum, swinging between states that life has never encountered. The moon's orbit changes too. Tidal forces shift. The rhythm of the oceans becomes something new. Coastal cities that have stood for millennia find themselves underwater at high tide, then dry at low tide, then underwater again as the pattern accelerates. And above it all, the sky changes. Jupiter, which has hung in the darkness as a steady point of light since the first humans looked up, begins to move differently. Its path across the constellations shifts. Its brightness varies. It becomes a wandering star in the oldest sense, a reminder that nothing in the cosmos is fixed. We would adapt, perhaps. Humans are adaptable. We have survived ice ages and asteroid impacts and the slow drift of continents. We would build new cities, new calendars, new myths to explain the changing sky. But adaptation is not the same as control, and this is the point where technological optimism collapses, because there is no machine we can build to stabilize the solar system, no engine powerful enough to counter Jupiter's gravity, no shield that can protect us from the redistribution of matter across 1 billion kilometers. We are not captains of this vessel. We are passengers, and the vessel is not under our command. The attempts to solve this problem, the serious proposals, the ones discussed in conference rooms and research papers, all end the same way, with the recognition that the forces involved are too large, the timescales too long, the variables too many. We could move Earth, in theory. Over millions of years, with technologies we do not yet possess, we could shift our planet's orbit to compensate. But moving Earth while Jupiter rearranges the outer system is like rearranging furniture in a house that is collapsing. It misses the point. The point is that we were never in control. We only borrowed stability from forces we did not create, and the loan eventually comes due. But this is not the end of the story. This is where the technical gives way to something else, something quieter, something that has nothing to do with orbits or probabilities or the slow dance of worlds. Because the question is no longer what happens to Earth. The question is what this reveals about us. We spend our lives inside an assumption so deep we rarely notice it. The assumption that the ground beneath us is permanent, that the sky will remain the sky, that tomorrow will resemble yesterday, that the world, in its essential structure, is stable. It is not an unreasonable assumption. It is, in fact, the only way to live. No human could function while constantly aware that the forces holding our world together are temporary, that the arrangement of planets is a coincidence of timing, not a guarantee, that we exist in a brief window of celestial calm, surrounded by vast stretches of time where that calm does not exist. But every once in a while, something pulls the assumption into the light. A discovery, a calculation, a recognition that the universe does not share our need for permanence. This is that moment. Jupiter hangs in the night sky, as it has for all of human history. Brighter than any star, steady, unchanging. It will continue to do so for generations yet unborn. Our great-great-grandchildren will look up and see the same light, in the same place, following the same slow path through the constellations. But they will know something we did not. They will know that the light is not a guardian, it is not a shield. It is simply mass, simply gravity, simply a sphere of hydrogen and helium following its own curve through space, interacting with everything it passes, indifferent to what those interactions create or destroy. And they will know something else, something harder to hold, that the stability they inherit is borrowed, that the orbit they stand on is temporary, that the world beneath their feet is not a fixed point in space, but a moving vessel, carried through darkness by forces they cannot control. This is not despair. It is not fear. It is simply scale. The universe is vast, not just in distance but in time, in possibility. in the range of configurations matter can take. We have occupied one small corner of that possibility space for an instant. And in that instant, we have told ourselves stories. Stories about protection, stories about purpose, stories that placed us at the center of something that was never about us. The truth is quieter. The truth is that the solar system does not need us to witness it. It does not need witnesses at all. It simply continues, rearranging itself over eons, scattering comets and reshaping orbits, and occasionally, by accident, creating conditions where life can briefly flourish. We are one of those accidents. A fortunate one, a conscious one that can look up and wonder. And that wonder matters, not because it changes anything, not because it gives us control, but because it is the only response adequate to the scale of what we have seen. We are not permanent. We were never meant to be. But for a few thousand years we have had the sky. We have named its lights. We have traced their movements. We have built instruments to see farther, and mathematics to understand what we see. And in that seeing, we have found something humbling. The same forces that threaten us are the forces that made us. The same instability that could unseat our world is the instability that delivered the building blocks of life. The same Jupiter that redirects comets also once captured them, held them, delivered their water and their organic chemistry to the inner system. The destroyer is also the creator, not by intent, simply by existing, simply by being large enough to matter. And so we return to the night, to the cold air, to the bright point of light rising in the east. It is still there. It will be there for a long time yet. But when you look at it now, you know. You know what it really is. Not a guardian, not a threat. Just a world, just gravity. Just one voice in a conversation that has been going on since before there was anyone to listen. And you are here, briefly, to hear it. That is enough.